Welcome back. In this video, you will learn how you can create a single node Databricks cluster on top of AWS. Okay, so up till now, we have created a new AWS account. We have created a new Databricks account and set it up on top of AWS. After that, we have created a new workspace inside the Databricks on AWS. And right now, I have logged into the workspace. So the next step is to create a single node cluster. A single node cluster is a cluster consisting of an Apache Spark driver and no Spark workers. A single node cluster supports Spark jobs and all Spark data sources including Delta Lake. A standard cluster requires a minimum of one Spark worker to run Spark jobs. Single node clusters are helpful for machine learning workloads that use Spark to load and save data, and also for lightweight exploratory data analysis. So let's go ahead and create a single node cluster, and for that either you can click this new button here and you will see the option for a cluster, or you can go to compute and from here you will see this option on the right corner to create compute, which in fact is a cluster. Okay, so this is how it's look like, and if I select new and then click on cluster, then again I land on the same page. Okay, so there are few things that you need to set. First one is the policy. So you have different policies here, which is the unrestricted access, personal compute, power use compute, shared compute, and shared legacy compute. I am going to use the unrestricted one. Then you have two options. Either you want to create a multi-node cluster or a single node cluster. Since in this video I am going to use the single node cluster, so I am going to select this value. Then let's go ahead, and here is the Databricks runtime version. Make sure that you select the latest version of LTS runtime. So this is the latest version having Scala 2.12 and Spark 3.4.1. Okay. Then we have the node type. Since I am using Databricks now just for demonstration purpose and not to perform large computations, so I don't need much resources, I'm gonna go with M6i large having 8 GB memory and 2 cores, and I think it's enough for this demonstration purpose. Then you have two options here. The first one is to enable the auto scaling local storage. It is not really important, so you might uncheck it as well, but I'm going to leave it as it is. Then the next option is the termination of the cluster. So right now it is terminate after 120 minutes of inactivity. This option is important because if your cluster keeps on running for a known period of time, then it might cause you charges from the Databricks or AWS as well. So you must set a time duration after which, if the cluster is inactive, then you must terminate the cluster. So 120 minutes means 2 hours, which is a long time. So I'm going to change it to 30 minutes. Then we have the instance profile. The instance profile actually provides the instance if we want to link AWS with it, but right now let's leave it empty. And then you have the advanced options. Inside the advanced options, you have different options. If you want to add the AWS account information here, you can see instances. Then you have the Spark that is showing you that what is a single node cluster and what is the master local. Then you have the logging, init script, and SSH. You can use all these if you want to add the instance information from AWS. Okay, I think all of this is good. Let's go ahead and click create compute. Okay, so you can see that it is loading, which means the cluster is being created. After a while, you will see that your cluster will be successfully created. So I'm going to pause the video and I'll come back once the cluster is created. Alright, so you can see that our cluster has been created and the cluster state has been changed to running. If I click on it, you can review all the data about the clusters either from here or from the summary. So you can see that we have a single driver because we created a single node cluster, and it is having 8 GB memory and 2 cores. And the runtime is 13.3x and Scala is 2.12. Then you have to see that this is the rate of the cluster, which is 0.76 dBu per hour. So this means that if you run your cluster for 24 hours collectively, then you will be charged $18.24 according to this rate. Welcome back. In this video, you are going to learn different ways of how you can upload data in the Databricks platform that is present on top of AWS using Databricks UI. In the previous video, you have seen how you can create a single node cluster on Databricks in AWS. Now in this video, I'm going to show you how you can upload data into the Databricks, and this can be easily done using the Databricks UI. Before going into the details of how you can upload the data into the Databricks, you have to make sure that the data is set up locally. Only then you can upload it into the Databricks account. But you should always remember that using the approach to upload the data into the Databricks platform using the Databricks UI is not a reliable and robust approach, and I'll tell you why later on in this video. But it is simple and easy to learn approach in order for the beginners to learn how you can upload the data into the Databricks. Enough of the talking now. Now let's go ahead and go into the details of how you can upload the data into the Databricks account. So in order to upload the data, you have to go to the main page of your UI, and you have two options to upload the data. The first one is this option on the main page where you can select upload data, and you will have the option to add the data into the Databricks platform. And the second option is to click this new button, and here you can see that we have the option of file upload and data. Both are similar, and let's say file upload, okay? Here you have an option. You can directly insert the data by clicking this browse here, or if you have a folder hierarchy, or you need to insert the data into the DBFS, which I am going to do in this video. So you have to click on this option which says upload to DBFS. Okay, so once you click on it, you will see that you will land on the DBFS page. And this is the place from where you can handle the folder hierarchy. And why am I stressing so much on the folder hierarchy? Let me show you. Let's go to my local system. And here you can see that this is the dataset that I am going to use. If I click on this folder retail_db, you can see that there are 6 different folders, and each folder have a separate file. So if I want to upload this retail DB inside the DBFS, so I have to create this folder structure in order to upload files in the respective folders. Okay, so you don't need to worry about the dataset. I'll upload it in the resources section. Now let's just go ahead and start uploading the data. So firstly, we have the categories folder. So I'm going to say categories here. And this is the, okay, firstly, let me create the retail_db. And then I am going to create category. Okay, then I am going to upload the data which was present inside the categories. So this is my retail DB, and inside the categories, this is the file that I am going to upload. And then click create table with UI. It is going to ask me to select a cluster. So I am going to select this cluster that I created in the previous video, and then click preview tables. Once I click the preview table, it is going to display me something like this. You can see that the table is in the loading state. Okay, so you can see that it is finished loading the data, but one thing to notice is that even for the integer values, it is selecting the data type to be string. So in order to correct this, you have to select this checkbox which says infer schema. So infer schema is going to set the data types of the columns according to the values present inside it. Okay, so now it looks fine. Now let's go ahead and click create table. It is going to take some time to create, and after a while the table will be created and data will be loaded inside the directory that we created. So I'm gonna come back once the table is created. Similarly, I am going to create a new directory, and the next one was customers. So now I am going to create this same hierarchy here, retail_db, and then I'm going to say customers. Okay, then I'm going to go to the customers, and then I'm going to upload it from here. Okay, so once this is created, you can see that file has been uploaded to file store, tables, retail DB, customers, and part this. Then I'm going to create table with UI. I'm going to select the cluster, which is this cluster, and then click preview table. Once you click preview table, it will be displayed here, and once again you have to click on info schema to match the data types according to the type of the data present inside the column. Okay, next simply click create table. So you can see that the data has been successfully uploaded here, and you can see that this is the data that we just uploaded. And similarly, you can create all different folder hierarchies to add the data. Another way to upload files directly into the DBFS is using the DBFS browser, but it may not be available to most of you. So to enable it, you have to go to your account setting, and then you have to click on admin settings. Once you are inside the admin settings, you have to click on the workspace settings, and then scroll down and go towards the advanced settings. Inside the advanced settings, you can see DBFS file browser options. Right now I have enabled it, so I have the DBFS file browser option, but maybe you guys have this option disabled. Then you simply have to click on it to enable it. And once you enable it, now you can click on this data option, and on the top you can see that we have browse DBFS option. If you click on it, you can see that we have file store option, and inside the file store I have the tables. If I click on it, I have this retail DB that I created, and if I further click on it, these are the 3 folders that I have created. So if I click on any of it, you can see that these are the data which is present inside this table. Okay, so if I want to create a new folder inside it, let me go inside the retail DB, and here let me just right click it and click create folder. So the next folder after departments is the order items. So I'm going to say order underscore items, and once I click create, the folder will be created. Then click on it to move inside the folder, right click it and click on upload here, and then select the file that you want to upload inside the table. So this is the file. Okay, click on done and your file will be uploaded. Let's do another one. Create folder, and the other one is going to be orders. Create the folder. Once the folder is created, go inside the folder and upload here. So this is a much faster version, but you remember that in the start of the video I said that this is not a very reliable and robust method, because you have to remember to maintain the file hierarchy, so you might not upload the data into the wrong folder. Okay, so this is why I said that this approach is not very reliable and robust. Let's upload the last file into the products folder. Go inside the products folder and click on upload here. Then simply upload the file which is present inside the products. Okay, once this is done, you simply have to click done, and now you have all the table, you have all the folder hierarchy and the files present inside the folder. So this is how you can upload files into the Databricks platform inside the DBFS using the Databricks UI. Welcome back. In this video, you will learn how you can develop a Spark application using AWS Databricks and a notebook. In the previous video, you have seen how you can upload data into the Databricks on top of AWS using Databricks UI. Now in this video, we are going to create a Spark application in which we are going to query the dataset that we uploaded in the previous video using a notebook. So the first step is to actually create a notebook. A notebook is nothing but a workspace in which you can write queries in any programming language to manipulate your data. So the first step is to create a notebook, and for that you have to click on new And then from the option, you can see the first option is notebook. You can click it. Once you click it, you will see that your notebook will be created. You can easily rename your notebook. I am going to save my first notebook so that I can keep track of which notebook has which code. Okay, then you can see this connect button which has blue dot beside it. If you expand it, you can see that actually this connect is showing you that this notebook is connected to which cluster. Okay, right now I have a single cluster, so it has automatically selected that cluster for me. If I have more than one cluster, then at the time of notebook creation, it will ask me that which cluster I want to connect to my notebook. Okay, then this is a programming language in which I am going to write you can either use Python, Scala, SQL, R or Markdown. Okay, so this is a place where I am going to write the queries. So the first thing that I need to write is the $sign. Then you have to write fs and ls. This is going to list all the directories for you. Then you can simply run it by clicking this play button. And it is going to run the query. And you can see that these are the directories which are present right now inside my Databricks. In order to add a new cell, simply click this plus button and a new cell will be added. Now, if I want to see the directories which are present inside this file store, I am going to say %fs ls and then I am going to copy this path and I am going to paste it here. Then after the file store, you can see that we have it inside the tables folder, and after the tables folder we have the retail_db folder. Okay, now let's run this, and once you run it, you will have all the directories in the output. You can see that these are the tables or these are the folders that we created in the previous video inside which we uploaded the files. Okay, so the files are uploaded in the correct directories. Let's copy this path and I'm going to write another query to see whether the folders have actually any data inside it or not. So I'm going to say %fsls. I'm going to paste the path, and inside the retail DB I'm going to check the orders table. Let's run it, and in the output you will see that it has returned as a single file whose name is part000, and this is the size of the file. Now let's copy this query again, and I'm going to create a new cell, and this time I'm going to run the query for the orders items table. It is order items, okay. Order_items. Let's run it. I'm going to do this to verify that both the files are of different size and they have different data inside it. Yes, the size of both files is the same. So this means that both files are different. Now let's move one step further, and I'm going to dive into the logic of how we can join these two data sets together and perform some aggregation or some other operations on it. So in order to join the two data sets, the first step is to load the data inside the data frame. So to do so, I am going to create a new data frame called orders, and inside it I am going to read the data using the spark.read.csv function, and here I have to pass the path of the file which I want to read. So firstly I want to read the orders file, so it is present inside this path. Let me just copy it, and inside the spark.read.csv function, the first parameter is going to be this path where your file is present, and then place a comma and I written the schema, and the schema is simply 4 columns. The first one is the order ID of the integer type, other one is the order date of string type, third one is the order customer ID of integer type, and the fourth one is the order status which is of string type. Now simply let's run it, and you will see that a new data frame object by the name orders has been successfully created. You can expand it to see the schema details of the data frame that we just created. Now let's quickly verify whether the data has been successfully uploaded inside the data frame object or not. For that I am going to say orders.show, and it is going to display me all the data which is present inside the data frame orders. Let's run it, and after a while you will see that it has displayed as all the data which is present inside the orders table. This means that the data frame has successfully read the data from the path which we placed inside the spark.read.csv function. Now let's create another data frame object to read the data from the order items file, and to do so you can use this query. Here I am creating an order items data frame object inside which I am using the spark.read.csv function, and the first thing you have to pass is the path of the file. So let's go ahead and copy this path, and I am going to paste it inside the single quotes inside the spark.read.csv function. Okay, once this is done, then you have to define the schema. So the schema, okay, this is not taking the next line. Okay, so inside the schema there are 6 columns. The first one is the order item ID, which is of type int. The second one is the order item order ID, which is integer. Then third one is the order item product ID, which is of the type integer. Then we have the order item quantity, also of integer type. Then we have the order item subtotal, which is of the float type. And finally we have the order item product price, which is of the float type. Now let's go ahead and execute the query to create the data frame object. And you can see that the data frame object has been created, and this is the schema of the data that is uploaded. Now let's quickly go ahead and run the show function on the data frame object. So I'm going to say order items dot show, and once I run it, it is going to display me the data that it reads from the file present inside the order items table. Okay, so this is the data present inside the table, which means that the data has been successfully loaded into the data frame. Okay, so the question arises is that why I want to join these two data sets together. This is because I want to calculate the revenue that is generated for all the transactions between orders and order items on daily basis. So in order to calculate this, I need to join the order file and the orders item file, and I'm going to group it on the basis of order date. And then using the order item subtotal, I'll be able to calculate the generated revenue that is calculated or that is generated daily. Another thing that I would keep in mind is that I'll keep the data from only those orders where the order status is complete or closed. This is because if you go ahead and see the orders table, which is right here, so you can see that there are different values for the order status. For some orders it is closed, for some there is pending payment, for some it is complete, and some it is processing. So we are going to take only those orders where the order status is either closed or completed. So we'll only consider the closed or completed orders as the revenue generating orders. Okay, so now let's go ahead and write the query for joining the two data sets. So I'm going to use this query. Here I have created a new data frame object. I've called it daily revenue. You can give any name to your variables. Then I'm going to join the orders table with the order item table. So I'm going to say orders.join order item, and the join condition is going to be orders order ID is equal to order items order item order ID. So it is going to join only those records where the order ID of the orders table is equal to the order item order ID of the orders table. Okay, let's run the query to see if it is successfully executing. Yeah, the join has successfully been done. This works fine, but if you remember, I said that I want to get only those orders where the order status is either complete or closed. So I am going to add a filter here. I'm going, so after the join and so after the orders and before the join, I am going to insert a new filter, and I am going to say the filter is gonna be order underscore status in. Okay, so the single quote comes here. So I'm going to say the order status in, and then I am going to pass complete. Okay, then place a comma and then say closed. Okay, so I have added the filter. I have updated the query a bit. So this is the daily revenue, which is our data frame object, and I am using orders.join. Up till here the query is the same. Then after the query I have applied the filter where the order status is in either complete or closed. Okay, so now let's execute the query to see whether it runs successfully or not. Okay, so you can see that it has successfully executed, which means that it has joined the two data sets on the basis of this condition, and it has filtered out the results where the order status is complete or closed. Now let's quickly see the data to check if it has get the data correctly after the join or not. And I'm going to use the show function with the daily revenue data frame, run the query, and after a while you will see that it will fetch all the data from the resulting data set after the join. So you can see that the order status for all the orders is either complete or closed. So this means that our filter worked correctly. So up till now our query is running fine. Let's go ahead and make some further changes to it. So this has just joined the data on the basis of this condition and then filter out the result. Now I am going to move one step further. I am going to use the group by clause, and I am going to group the data on the basis of order date. Okay, now let's run it again to see that if it runs correctly or not, and you can see that the query is successfully executed. Now in order to calculate the aggregated daily revenue, I am going to move one step further and use the sum function, and I am going to sum the order item subtotals. Okay, and you can also use an alias for it. Okay, so this looks fine, but we should not run it right now because the sum function has not been imported. Okay, so let's go ahead and add a new cell above it, and I'm going to say from PySpark .sql.functions import sum. Let's run it to import the library inside the Databricks, and once this is done, now you are all ready to run this query. But first let's provide it an alias, and I'm going to say .alias, and I'm going to call it revenue. Okay, change the double quote to single quote here. And the last thing that I'm going to do is I'll enclose all of this inside a bracket, and I'll use the aggregate function to calculate the aggregation of the daily revenue. Okay, this looks good now. Let's run it to see if it is successfully executing or not. Oh, yes, it is successfully executed. Now let's just go ahead and see the data. So I'm going to say daily revenue, and I'm going to use the show function inside. Let's run it, and now you will have a new column called the revenue that will contain the daily revenue for the orders. So you can see that for each order date it has calculated as the revenue of each day. You can see that the revenue has a lot of values after the decimal point. So let's round it off up to 2 decimal values. But before that we have to import the round library. So I'm going to run this cell again. And now the round library has been imported. And here inside the aggregate, now I'm going to use the round function. And I am going to close it here after the comma. I want to get the revenue up to 2 decimal places. So I have placed 2 here. Let's execute it. And it has successfully executed. Now let's run this cell again, and you will see that now the revenue will be up to 2 decimal places. Yeah, this looks good now. Okay, let's do one more thing. I'm going to order it on the basis of order date. So I'm going to say order by, and then inside it I'll say order date to make it more presentable. Now let's run it again. This runs fine. Now we'll run this cell again. and you will see that now the order date is the column on the basis of which all the data has been ordered, and the revenue is up to 2 decimal places. So this is how you can develop a simple Spark application on Databricks which is present on top of AWS by creating a simple notebook and running some Spark commands on it. So that's all for this video. I'll see you in the next one.